Well, shalom, ladies and gentlemen. This is Kazoo Cruiser with another episode of how I'm fixing this truck. What you're looking at is a hole that is supposed to be receiving the PCV signal from this hose. Now that's a 3/8 inch hose, and it goes back to the PCV valve on the back of the engine. It runs around here and it's supposed to go into the hole down there. Now how's it going to do that, you might be asking? Well, let me show you. This was what was in it. Now, I don't know what this is. At least I didn't know what this is until doing a lot of research on the internet. It's brass and it's threaded, but I didn't know what the pitch was. I didn't know what the size of the pipe was. And I didn't really know how I was going to fix this problem. I've tried to fix it a couple of times, fill out use Teflon tape to try to push the gaps out of it, but it doesn't work, and it creates a bad vacuum leak. Right there at the intake manifold. The carburetors on these cars are real sensitive to vacuum signals for proper fuel blend. To keep it from stumbling around and running lean and everything else. It's a parasitic vacuum loss, and it creates a problem because the carburetors can't draw air properly. Of course, the fuel vaporizes, whatever, and all of a sudden you got a lean roll condition, lean misfire condition. It doesn't fix itself; it just gets worse, and it mimics fuel percolation and vapor lock. So I've got to make sure that I don't have any vacuum leaks before I go any further. I've got this stumbling around problem, and I've got to fix that before I've got to fix the vacuum leaks, make sure they're all sealed up before I have a problem resolution. I've got to make sure I don't have that as a problem. So here's what I bought today. You can see it's about the same length as my defective part. I originally thought of trying to buy a die for this and clean it up, but then when I finally did my research and found out that it's 8 by 27 and 1/8. It's a 1/8 pipe, and the dimensions here is on this is 1/8 by 1.5 inches dimensional length, and it's got that 27 impossible to find unless you have a tap, which I actually paid close to $7 for. So I can make my new hole clean it up, because all that brass transferred from the original piece and ended up contaminating the threads. So I've got to clean those threads out, and I'm going to use this to do it. And I'm also going to use greasoline on the tap to catch the little metal bits so they don't get drawn down into the engine. They probably would pass through without any problem, but I just don't want to make a problem. I don't want to create a problem. So if I can trap the problem, use grease on the bits. It collects the dirt, and I'm going to start using with a pair of vice grips. Hopefully we'll see if this will work. If I don't have to take the carburetor off, I'd rather not. But then I thought about it. I could have replaced it with that original brass fitting, because I located one. But then I found this one. It's actually 2 inches long, and it's galvanized steel, which means it's a lot more resistant to thread degradation, and I can cut it down to the 1.5" I need and get rid of the threads on the bad end, on the end I don't need, and then I just have my problem solved. I'll put another video together once I have this thing completed, and at least it'll be an archive out there if somebody runs into this kind of same problem on an 81 straight 6 Chevrolet 250 engine. Thank you for watching.